Welcome to The Explainer. We're diving into something massive today. We are unpacking the rise of large language models, or LLMs, and looking at exactly how these incredible AI systems are absolutely rewriting the rules of our daily knowledge work. It's a total technological earthquake, and we are right in the middle of it. So let's just cut straight to the chase and ask the question that is literally on the minds of professionals everywhere. As AI rapidly moves from just a cool research concept to something you use at your desk every single day, how is it actually changing what it means to go to work and produce value? The pace of innovation we are seeing right now, it's practically vertical. Just from 2018 to 2024, the sheer volume of research papers on LLMs fine-tuning and alignment spread like wildfire. We went from a handful of theoretical musings to tens of thousands of highly specialized breakthroughs in the blink of an eye. To make sense of all this without getting completely lost in the noise, here's our game plan. 1. The LLM explosion. 2. Redefining knowledge work. 3. Under the technical hood. 4. Training and efficiency. And finally, number 5. The future road ahead. Let's get right into it. All right, starting with part 1, the LM explosion, and mapping out this wild ecosystem. Right now, there is a massive tug of war happening in the AI world. On one side, we've got open source models. These are architectures that anyone, anywhere, can download, tinker with, and modify. On the flip side, we have closed source models. These are the highly powerful, proprietary systems locked tight behind corporate doors where you can only access them through APIs. It's a fascinating divide that's shaping how fast researchers can innovate versus how securely companies can deploy their products. And man, the historical progression here is moving at light speed. The older foundational models are already getting crowded out by what we call instruction-tuned models. We've very rapidly shifted away from machines that just basically guess the next word in the sentence to sophisticated assistants that actually understand and follow human instructions. Which brings us to part 2, redefining knowledge work. This is the big paradigm shift. There's this fantastic piece of research from the ACM that really hits the nail on the head. The key phrase here is specifying their desired outcome in natural language. Think about that for a second. For decades, we had to learn the computer's language, syntax, coding, navigating endless software menus. Well, not anymore. The computer finally learned our language. You just state what you want in plain English, and the machine figures out the rest. In the real world, this is an absolute game changer for productivity. Surveys of early adopters show they're already using these tools to totally skip the daily drudgery. Instead of staring at a blank screen trying to draft an email or banging your head against the wall debugging a simple script for 3 hours, workers are using LLMs to just do it for them. It completely frees up your brain power for the high-level, creative strategy that actually matters. Okay, moving to section 3, under the technical hood. Let's look at the big picture here. So, how does all this actually happen? Well, it's not magic. It's a massive, multi-stage engineering pipeline. It starts with the model's birth in pre-training, goes through refinement via fine-tuning and optimization, passes through some rigorous evaluation, and finally reaches deployment into the apps we use every day. Let's start at square one of that pipeline, tokenization. Before an AI can even begin to understand your natural language prompt, it has to chop it up. AI doesn't read words the way you and I do. It parses your text into these tiny mathematical puzzle pieces called tokens, which could be whole words, subwords, or even just single characters. It is the essential translation layer between our human text and the machine's math. Next up is a super important concept called attention, and it does exactly what it sounds like. It helps the model figure out which specific words in your prompt are actually important. But calculating that requires a staggering amount of memory. To solve this, engineers came up with incredible innovations like flash attention. It cleverly reorganizes data on the actual hardware, letting the system process massive documents all at once without hitting severe memory bottlenecks. Now, mathematically speaking, these attention patterns take on a few different shapes. They can process language causally, meaning they only look backward to predict the next word. Or they can process contextually, looking at the entire sentence all at once to grasp the broader meaning. This structural choice is exactly what dictates whether a model is better at, say, writing a brand new story or analyzing a document you already uploaded. Which naturally leads us to section 4, training and efficiency and processing at massive scale.
Here's a wild thought for you. You absolutely cannot fit a model with 100 billion parameters onto a single computer chip. It is literally impossible. To process at this mind-boggling scale, engineers have to shard and split the data and the model itself across hundreds or thousands of physical GPUs. They use brilliant strategies like data parallelism to share data batches and tensor parallelism, which literally splits the complex math equations right across different chips.
The ultimate synthesis of all these techniques is what engineers call 3D parallelism. By combining data, tensor, and pipeline parallelism all together, the system can distribute these insane processing requirements. It basically allows the AI to learn efficiently without melting the physical servers.
But underneath all that heavy-duty hardware distribution, you still need some seriously precise math to keep the whole operation stable. Components like activation functions dictate exactly how signals pass through the neural network. Meanwhile, positional encodings, like rope, give the model its sense of word order. Without these intricate mathematical foundations holding it together, the AI would just spit out total gibberish.
Finally, let's zoom out to Section 5. The future road ahead, our integrations, and our challenges.
Here's a little secret. Raw, out-of-the-box, pre-trained models are actually pretty terrible at following instructions. The real magic, that happens during aligned fine-tuning. This is where the models are meticulously trained to understand human preferences, respect safety rails, and grasp what the user actually wants, transforming them from glorified autocomplete engines into genuinely helpful assistants.
But look, it's not all sunshine and rainbows, right? Despite this massive paradigm shift, we have to be totally objective about the major hurdles the research outlines. These models can still hallucinate fake facts. They can memorize and repeat toxic or biased data. And the computational costs, both for the hardware and the sheer electricity required, are staggering. Not to mention, seamlessly blending vision and audio into the mix remains a deeply complex challenge that engineers are fighting to solve every day.
Yet, even with all those hurdles, our ultimate goal as knowledge workers is crystal clear in the recent surveys. We don't just want some standalone chatbot living in a separate browser tab. People are imagining a very near future where these LLMs are deeply, natively integrated directly into their personal workflows and private company data. We want a true, context-aware co-pilot that knows how we work.
So, I want to leave you with this final provocative thought. As these incredible parallel processed architectures overcome their current limitations, and as they become completely woven into the fabric of your email, your documents, and your daily tasks, what happens to your role? How will you adapt and elevate your own career when the machine can finally handle the tedious work for you? Thank you so much for joining me on this explainer. I really hope this helped you see exactly how the rules of our work are being rewritten.